What is going on? So I am on a problem-solving frenzy tonight. I'm just solving a lot of problems, just going through, making the rounds. So I don't know how many problems I've solved, but I've been going since Sudoku. I solved Sudoku, and then I've done at least 4 problems since. Like I did an interesting problem with array, the product of the elements in the array, except you take the product of every element in the array except for the index. When you add one index, you take the product of every element at every other index and put it at that index, but it not include the index as the value at the current index, if that makes sense. So it's kind of like an exclusive multiplication. Like you multiply every element in the array and put it at the current index, but do not multiply it by the element that's currently at that array. And other problems were like solve Sudoku. Solve Sudoku was using like a DFS and backtracking, checking if Sudoku is valid, which is much easier. That's just a straight up hashing type of problem, hash tables and stuff, using data structures. And then the other problem was using like a bidirectional approach where you want to, the bidirectional approach was the one where we did the array products. The other problem that I solved was like a meeting room problem, or it was called time planner, but it was basically finding the overlap between two schedules and making sure the overlap is greater than a certain duration, and which was an interesting problem of just moving 2 pointers basically across the schedules until we get the correct overlap. The other problem was, what was the other problem? That may have been it, actually. Let me see, because I may have, if I did do another problem, it would be on here. No, I didn't. Okay, but now I'm doing this problem, and I'm just going marathon. So for this problem, so what we're going to do is we're going to use 2 pointers, and the idea is that if you think about this conceptually, you're going to move the pointers. There's 2 conditions in which you want to move the pointers. If the pointers are pointing at an element in the array that's non-zero, you want to move both pointers, and you're always going to swap. So you're always going to swap as long as the element is non-zero. If it's 0, then you're not going to do anything. You're not even going to update the thing. So here we go. So we have 2 pointers here. Now since this is a 1, we're going to move both pointers to the next element. Since this is a 10, we're going to move, this should be 0, 2. Okay. Since this is a 10, we're going to move both pointers to the next element and swap it, but we're swapping it with itself, right? Then when we get to the 0, we're not going to move the one of the pointers. Because one of the pointers we want to kind of point to where our last 0 was found, and we move one of the pointers. Oh, this should be like that. So we move this pointer, and now what we do is, since this is not, we're going to swap these. So we swap these, right? And when we swap, we move both pointers. So you can see how this will work, and I'm just going to keep going, keep swapping until it gets to here and here. So this will be an 8, a 3, and a 0. Now when it's here, since these are both 0, it's just going to keep my last 0. It's not going to update my last 0. And it's not going to swap. It's just going to keep moving this one until it's a 6, and then swap that 6 with that 0. So that's how it works. So let's see how we would do it. So I keep track of the last 0. Initially I want to say the last 0 is at 0. And then I would do for I in range of length of array. Take, wait, what am I doing? Okay. Alright, let's get back in the into the focus here. So I want to take, basically this is just me saying, that's what I'm trying to record here, you know, just me saying, and like going like, what am I doing? I don't know what I'm doing. That's basically the whole point of me recording these videos. Yeah, I just did another, and I did another one. Okay, it's infinite recursion. Okay, what was I doing? Right, so if array I does not equal 0, that's when you want to swap. So you want to update the last 0 by 1, and you want to swap the two elements, array I and array last 0 equals array last 0. This is the technique to swap in Python, array I. Okay, so that's actually it, I believe. And you want to return an array. So basically, that's going to do this. It's going to update where your last 0 is at. And I mean, if the array is equal to 0 at that point, you're just not going to update your last 0, because that makes sense, because you don't want to move the pointer that's supposed to point to your last 0. And anytime you hit an element that is not a 0, you want to switch that with your last 0. And since last is the wrong word to use, it's not your last, it's your earliest. I guess the earliest 0 that you see. The earliest 0. I'm just doing that because I don't know why I kept calling it last 0. I just kept calling that, but like it's really the earliest 0, the 0 you see first in the array. And you keep moving that 0 whenever you swap it with one element, but it only moves by a value of 1. So there's a linear scan and constant space. But yeah, so that's how you solve this problem. Move 0 to n. I'm probably going to do another problem and make another recording in a bit.